Let us compare finding the area of a trapezium with finding the area of a parallelogram. We are saying that a parallelogram is actually a trapezium. In the set of all trapezia, or some may say trapeziums, the set of parallelograms is a subset. A parallelogram is a trapezium, and we will find the area of the parallelogram by making use of the area of a trapezium. Then we will return to the parallelogram to find its area in the typical way and show that those two values are the same. A parallelogram, if we are finding the area of a parallelogram, we consider that it has a base and a height that is perpendicular to the base. The base will therefore be the length of this side. Well, this side will be the base, and no doubt that this side is also the same length as the side that we are using as the base. Because, of course, for a parallelogram, opposite sides are equal and opposite sides are parallel. So we are considering that it has a base and a height that is perpendicular to the base. B and C, as we have here, are the two parallel sides. This is the formula for finding the area of a trapezium. Finding the area of a trapezium, it does not matter what symbols we have here. All that we need to know is that the two that are added within the brackets are the two parallel sides. And of course, A will be the perpendicular distance between the two parallel sides. It doesn't matter. These are the two parallel sides. It could be K and Z. Doesn't matter. These are the two parallel sides, and irrespective of what this symbol is, it is the perpendicular distance between the two parallel sides. So we have it, B and C are the two parallel sides, and we will choose opposite sides of a parallelogram are parallel, so we may choose any two opposite sides. B will be 8 and 8 again. The two opposite sides are parallel. A is perpendicular to the two parallel sides. A is the perpendicular distance between them. The height that we have here is already perpendicular to the two parallel sides. We may therefore use the height of 5 centimeters. It is perpendicular to these two parallel sides. Now, we are not saying that these are the only two parallel sides, because they are not the only two parallel sides. But we are using these two parallel sides for the intents and purposes of finding the area of the parallelogram, which we are finding under the assumption that it is a trapezium. These other two sides are also parallel, but we are not focusing on those two sides. The perpendicular distance between the two parallel sides is already given, because the height that we consider for the trapezium is perpendicular to these two sides. Simplify the arithmetic expression. 5 over 2 is retained. 8 plus 8, that's 16, and we will simplify by a common factor of 2. 2 into 2 is 1, and 2 into 16 is 8. 5 times 8, and the area is 40 square centimeters. Going to the parallelogram and finding its area in the typical way, the area of a parallelogram is equal to base times height. Base times height. We discussed before that the base is 8 centimeters, being parallel and equal to this. So this is the actual base, but it is parallel and equal in length to this side. So we will say that the base is 8 centimeters. And of course the height is 5 centimeters. We therefore receive 40 square centimeters for our area, which is the same as what we have when we consider this parallelogram to be a trapezium. On this occasion, we will not use numbers, but show that the proposition is generally true, that the parallelogram is also a trapezium. A parallelogram is considered to have a base and a height that is perpendicular to the base. B and C are the two parallel sides of the trapezium. Opposite sides are parallel, so we may choose any of the two pairs of opposite parallel sides, but we are choosing the lower and the upper side on this occasion. That one will be B and the other will also be B, which we intend to be the length of the base of the trapezium. Which we intend to be the length of the base of the parallelogram. A is the perpendicular distance between the parallel sides. And here, the height is already given to be perpendicular to the upper and lower sides. Therefore, what we have here, which is H, is already perpendicular to the two parallel sides, and therefore will take its position right there. Simplify the algebraic expression, and the first thing that we will do is consider that B plus B is 2B. Next, we will simplify by a common factor of 2. Those are cancelled, and all that we have is H times B, of course, that we know to be B times H. Multiplication is commutative. And it is the same thing that we already have here. The area of a parallelogram is the product of the base and the height, which is perpendicular to the base. The area is therefore B times H. The area of a parallelogram is shown to be equal to the area of a trapezium if the parallelogram is treated in the same way that we would treat a trapezium. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.